Hey guys, Andrew with Andrew's Air Cool Technology back again. I'm going to talk a little bit about this test rig behind me and what it does and how it works and what equipment I'm doing to measure the airspeed and CFM and pressure that my new lightweight cooling fans actually produce relative to the OEM fans. So right now in the test rig behind me, there is an electric motor you can see kind of in the very far side. It's got an adapter to it to hook to the alternator. It's lined up on there, nice and level. And of course the alternator, and I got a full mock-up test engine here. And obviously it's an empty engine. There's no crankshaft or anything in it, pistons or anything like that. It's just the outer shell, right, for testing airflow. But it has everything that should be in it. This is set up right now with the OEM doghouse fan shroud. That's from a '73 Beetle. The OEM tin, OEM heads with the deflectors underneath that are installed in there. It has all the tin around. It has all the internal stuff. The flaps are in there. Spark plugs are in there. Spark plug wires are connected. I have a throttle tube on there. So and of course it's got the oil cooler on the other side. You can't see it from this angle, but the oil cooler's on it, and all the tin around the oil cooler with the exit out the back. So it's a full cooling system, the way it would be installed in the car, with all of those things that provide static pressure, so that you get the same exact environment that you would have installed in a car. So we've got that. And of course, the fan is turning at a set RPM because the electric motor turns at 3,450 RPM, and so every test is exactly the same RPM. So unlike testing on an engine that's running on a test stand or in a car, these create reproducible results. So I can switch the fans out, start it back, hook everything back up together, start it back up, and it's going to spin the exact same speed as it did for the other fan. So this gives me the ability to create comparisons that are actually accurate. Now you see this really long tube, and you'll also notice back here that it's black. This is closed cell foam that has been shaped to fit the fan shroud. So when I push that against that, it creates an airtight seal. So all the air is only running through the length of this tube. Now this tube is long enough and large enough to comply with the ASTM standard for measuring airflow in ducted systems like this. It's large enough to make sure it doesn't interfere with velocity ring on the inlet as well. So there's nothing, there. It's plenty large enough. And at the kind of front of that, you'll notice this device with the tubes on it. There's a pitot tube, and this is a manometer, and it's uses a pressure differential sensor in it, and it connected to the pitot tube. I don't know if we can. I'm going to move the camera, see if you can kind of easily, so you can kind of see the pitot tube. There, that's a little better. You see the pitot tube, sticking up in there. There's a hole in there. It's sticking up in there, and it's pointing. And we'll go to the end, and I'll let you see that as well. It's pointing out that way. And so as air comes in, and it's got a velocity stack on the end of the tube, so that it doesn't create abnormal pressure on the inlet of that. And it's right in the center of that tube, so we're just measuring that airflow as it comes through. And the software that records the measurements from the manometer does adjustments for, you can see here I've got temperature and humidity, and I've got altitude as well, barometric pressure. It compensates for that to give you an accurate number regardless of what the air density might be at any given point in time. So that's another kind of real key feature of this test setup with the equipment, is not just using the pitot tube and the thermometer versus trying to do like an anemometer instead, which is a lot of people will do. Anemometer, and you just put it up there and then do some calculations by hand for CFM. That doesn't really work very well. It doesn't work well because one, the airflow is not uniformly distributed on the inlet. So wherever you put the anemometer, right, you're going to get different speeds. If it's in the very center, it's going to be slower. If it's in more towards the side of these centrifugal fans, let's say you measure kind of right in this, towards the center. That's going to have the least amount of airflow. You measure towards the edge of this, the airflow is going to be much, much faster. So you don't get a uniform distribution of airflow. And using that approach, and then try to calculate it based on the diameter of the inlet to the fan shroud, it just doesn't work. And it doesn't give you any adjustment for air density changes, so altitude, temperature, and humidity. So this setup gets very, very accurate results, and as the temperature changes in here, I have to configure the software to say what the temperature is, etc., so that each time I do it, I actually reset the temperature if it's changed. So I configure that measurement every single time to make sure I get accurate results. And this has been working great. I get very consistent results. I can do this stuff over and over regardless of whether it's really cool in here or really warm in here. Get the same numbers no matter what. And so that's what we're doing there in terms of that. And let me sling you around. You can kind of see we'll do this kind of slow and try not to make anybody sick. Looking at that, you can kind of see the pitot tube in there. You can see all the way into the fan, and that's how we measure it. And of course, where that pitot tube is in height is also important to get good, consistent measurements. And so I actually have where it's clamped to the welding table fixture. I have that marked, so I clamp it exactly in the same spot every single time. So I get, again, consistent, accurate, repeatable results. That's the big deal. So yeah, we've done great work with this. This took a while and I upgraded the electric motor because the original one I had was a little too weak, I think, for doing the accurate testing. So this is a test rig. This is everything that's gone through. So all the numbers that you'll see eventually when I publish all the numbers will be based on what came out of this test rig, and it will transfer to the running engine perfectly. It will be exactly the same, and relative to whatever your setup is, whatever ventilation, static pressure you have in your particular car, in your setup, you still get similar percentage differences for what I'm gonna publish. So that's the real exciting thing, is that there really isn't a use case where somebody, because of their particular engine car combination and what they've done, might get not good results. So we don't want a product that isn't consistently good for every single person, regardless of what they've done engine wise or car wise. So that's really the key, and why I've worked so hard on this to solve that problem, because most people have been very happy with the existing product, but it doesn't make me happy when some people just doesn't work for. So I'd rather have something out there that I know for sure it'll work consistently great for everyone under every circumstance. That's the thing. And so that's what we're doing. These are coming, hopefully I should have a call next week with the vendor on the equipment. Hopefully we'll get good news that it's on its way, and we'll get these manufactured as quickly as possible and get stuff out to you. So appreciate again the business that I've sold out. All the ones that I've made and everything is great. Been happy to see a lot of customers having great success with it, and this one I think will be even better, and there won't be really any cases where someone just doesn't get good results. So really appreciate that. If you guys are real interested in the new one as well, you can still go to the online store, and if you click on the product image for the lightweight cooling fan, it takes you to the product page where you could normally add it to cart, but it'll have a button instead of the add to cart. It'll say notify me when back in stock, and you can click that, and it'll create an automation in my online store, so that when I update the inventory for that product, you'll actually be able to get automatically notified that it's back. So as soon as I have them and they're ready to sell, you'll be able to purchase. And like I said in the other video, I'm going to have versions for early VW, pre-71, the doghouse, which we see in behind me, and the Porsche 356. So customers were asking for that, and so we're going to deliver that since it's not much different than doing the early VW. So appreciate it again for all the business, and we'll talk to you later. Thanks. Bye-bye.